Hello everyone. So today my topic, what I'm going to cover is error control, stop and wait ARQ. As we already know, error control is just a method of error detection and retransmission of data which is lost or damaged. Now, what is negative acknowledgement is that anytime an error is detected in an exchange of data between sender and receiver, that is known as a NAK or negative acknowledgement. And if that is returned, that is NAK frames are returned and transmitted, that process we know is known as automatic repeat request, that is ARQ. Now there are two functions of ARQ. One is allowing us to know that frames are lost or damaged, and the second one is that it also helps in retransmission of lost frames, that includes ACK and NAK. Now, ARQ error control is implemented in the data link. That means there are two parts. One is data link, which the sender sends to the receiver, and ACK part which the receiver gets. So now this is known as stop and wait ARQ. Now it is a form of stop and wait control, flow control extended to retransmission in case of lost or damaged frames. Now this stop and wait ARQ is an extended form of stop and wait lost flow control, which helps in retransmission of lost or damaged frames. Now for this transmission to work, there are four features that are added to the basic stop and wait to basic ACK. The first one is the sending device keeps the copy of the last frame transmitted until it is received as an acknowledgement for the frame. Keeping allows the sender to retransmit. Now if we see, when a sender sends a file or a data frame, and if that is damaged or receiver does not accept it or acknowledges it, the sender will send it again. That is known as retransmitting or keeping it properly. Now for identification purposes, we use numbers 0 or 1 for ACK and data frames. We use it alternatively. Now for example, we see here data equal to 0, acknowledging data 0 is the data sent by the sender to the receiver, and ACK 1 means receiver is acknowledging it. Now this numbering allows the identification of data frames in case of duplicate transmission. Now if error is discovered in data frame indicating now if we see an error or a damaged or lost frame due to the extensive noise, as we know that NAK frame is returned. This NAK frames aren't numbered and they tell the sender that it is not received and acknowledgement has not been made. So the sender will transfer or transmit the data file again. This is the process. Last step is sending file is equipped with the timer. A timer will be there which will acknowledge which will see the expected time of acknowledgement, and if it is not received within that expected time, it will send again till the file is received. Now this first one is the flow chart of error control and two different types of error control. One is stop and wait ARQ and the other one is sliding window ARQ, and which are further subdivided into go back and then and selective rain. Now first one here we can see is a stop and wait ARQ in damaged frame. As we know, first figure we have a sender and a receiver and as I said, the steps involving are numbers 0 and 1, data 0 ACK1, data 1 ACK0. So this is the pattern which I was saying. Data is given sending 0 and ACK is receiving 1, data is getting 1, ACK is receiving 0. This is the format in which the data is transmitted between sender and the receiver. This is the normal process. Now we see in the next one, it's the lost frame. uh, in stop and wait ARQ lost frame, when the sender sends and data frame is lost, here we see that the data frame is lost and there is nothing to receive. So when that timer does not the receiver does not acknowledges the timer or the time, the sender will send again the data. This data again is sent and the receiver acknowledges it, and data is 0, ACK will become 1. In the next one, ACK will become 0 and data will become 1. This time difference is known as timeout between two datas which were lost. Now there is a third case in which the ACK file or the receiving file is lost. In this, when the sender does not acknowledges it, the sender knows that the file he is receiving is defected due to the noise. So the sender will send the last signal which it had, since sender stores all the signals which it sends, so it will send again. Now this time is also known as timeout. Now damage frame, when a frame discovered by the receiver is containing an error which is mostly due to noise, it returns a NAK frame and the sender retransmits the last frame. This is known as damaged frame. The different types of lost frame are lost data frame and lost acknowledgement frame. This is lost data acknowledgement frame, and the previous one is lost data frame. So this is my topic. Thank you. I hope everyone understood it.